Okay, so I'm just going to go through the solutions to the homework from Tuesday's class. Um, okay, so in the homework, you were given a table that contains data comparing moons within the solar system to Earth. Study the information given and answer the questions that follow. So, like I said, the reason I chose this question is because something similar to this came up on the Junior Star last year, and it kind of threw people because it wasn't relying on anything you'd learned off. It wasn't like list 3 moons in our solar system, like, which you can learn off and reproduce. It was this idea of like analysis of data, um, which kind of links in with the whole nature of science thing, because it is important that you can analyze data and look at data that you may never have seen before. So anyway, that's why I gave it to you, to have a go at it. So I have the first two done here. Comparing the data above, list the moons in increasing order of gravity. So starting with the lowest gravity. So gravity is the second column here. The smallest number is 0.0057 for Phobos, so put that first. Next then is 1.315, which is Europa. Next is 1.352, Titan. Next is 1.428, which is Ganymede. Next is Earth's moon, and then next was Lo. So that's them in increasing order, so going this way, they're increasing for gravity. In part B, you're asked to create another list of moons above in increasing order of diameter. So starting with the smallest diameter, which is 18 kilometers. It increases to 347. Oh, did I do that one wrong? Oh no, I'm right. So the smallest is 18. Next is 3121, which is Europa. Yeah. Next is 3474, which is Earth's moon. And next is 3642.2, which is Lo. Next is the 5149, which is Titan, and then the 5262, which is Ganymede for diameter, which you'd expect because Ganymede was the biggest moon. So it says analyse your lists of gravity and diameter, and do you notice any pattern, and what conclusion can you draw from this pattern in relation to gravity and diameter of the structure? The first two obviously are consistent in both lists, but after that it gets a bit mad. So Titan is third on the gravity list, but it's fifth here on the diameter lists, and then fourth here and sixth. This is the fifth in terms of gravity, but it's only the third in terms of diameter. Okay, so I suppose, do you notice any pattern? No, not really. There isn't really a pattern there. I can tell you that gravity, the size of gravity, is dependent on two things. So it's dependent on the moon or the planet, whatever, on the radius, which is obviously connected to the diameter, but it is also dependent on the mass of the planet, so how heavy the planet is. So gravity is dependent on the moon's radius and mass. So what we have here is sort of half a story. You wouldn't really be able to pick out any kind of pattern unless you had a mass as well, which we don't have. So yeah, we can't really draw a pattern in relation to the gravity and the diameter. There's a Leaving Cert physics formula which relates them, so that's the reason I can tell you that there definitely is a relationship between them. What actually happens is, if the radius were to get 4 times bigger, so if you're comparing two planets and one had a radius 4 times bigger than the other, then on the bigger one the gravity would half, but you still have to take into account the mass. So like, you can kind of look at this and say that this has a big kind of diameter. Ganymede here has a big diameter. So the fact that it's the biggest diameter, you expect it to have the smallest radius, but that's not taking into account the fact that it's got a big diameter. It's probably pretty heavy. So you've kind of got two things battling each other there. the radius and the mass. So anyway, without my little additional information, do you notice any pattern? No. And what conclusions can you draw? I mean, if I was simply drawing conclusions from that diagram, I would probably draw a conclusion that there's no relationship between the size of the gravity and the diameter. I'm telling you that there is a relationship, but there's two factors involved, and we're leaving one of them out here, so it's impossible to see a pattern. Select the moons with the lowest gravity and the highest gravity and describe what a person on Earth would experience if they were to stand on these moons. Okay, so the lowest gravity was, this is gravity, isn't it? Yeah, was Phobos. So I suppose with a gravity of, no, that's the diameter. Sorry. This was the gravity. With a gravity of 0.0057, like, that is 1,721 times smaller than the gravity on Earth, so it would be virtually impossible to stand. Describe what a person would experience if they were to stand on each of these moons. It would be impossible to stand on that moon. There's nothing holding you there. It's not a particularly, like an 18-kilometer diameter. It's not a particularly big planet, so it's not, obviously doesn't have a very big gravity, and then you certainly don't have, any of us don't have a big enough gravity to make any significant difference there, so you just wouldn't be able to stay there. There's just nothing holding you there. You can see here it doesn't have an atmosphere, so if there's not enough gravity to hold an atmosphere, yeah, you just float away. The highest, so low was the highest, right, 1.796, so like that's very comparable to the Earth's moon. So if you were to stand on that planet, you would require similar equipment to what is required to stand on the moon. You know, you would be able to stand there. However, if someone were to give you a kick and send you off the surface of low, you would certainly float away without anything to bring you back. So the comparison there will be very similar to the comparison between Earth and our moon. Yeah, so it's about 5.5 times smaller than the gravity of Earth, so way more comparable. Definitely, like the moon is 6 times smaller, so you'll definitely be able to, with equipment, you'll definitely be able to stand on the surface, but yeah, you wouldn't want to be jumping too high because you'd take off. And using the information within the table, select the moon you think could possibly support life and give 2 reasons for your answer using the data. So I saw one there when I was reading it. Yeah, this is probably the one I would pick. So gravity is, you know, not tiny. It's 8 times smaller than it is on Earth. So, like, you know, it's still in the realm. It's not like Phobos down here where it's completely, like, you would definitely, you know, we'd have to adapt, and we'd have to be careful, you know, that you didn't hit anyone too hard, or be able to kick a football because it would definitely take off. But it's comparable. The diameter is quite similar to the Earth's moon, so, you know, again, that's why the gravity is similar as well. Temperature-wise, like, it's very close to Earth on the high side. It only goes up to 40 degrees. Now, we would have to do some adapting to the low side because it goes way down. But the big thing is it has an atmosphere made of oxygen within some water vapor. And we need oxygen to survive. We need water to survive. So they're your building blocks of life, really. So yeah, I suppose if I were to pick 2 reasons, it would probably be the upper temperature being very similar to what we're used to, and if you'd have to include the fact that it has an atmosphere of oxygen and water. So that would be my choice for which moon could possibly support life. All right.